Hey, welcome back to Mr. P. Helps with Pre-Cal. This is Unit 5, Topic 1, Lesson number 3. So we are going to be talking about multiplicative inverses of a matrix and finding the determinants. Starting off with the warm-up, determine the order of the matrix. So that would be the rows and the columns. So that's a 3 by 2. And I know it's a 3 by 2 because it has 3 rows and 2 columns. This is not a square. So a square would have to have the same amount of rows as it does columns. This is a square, so this is yes, and this is a 2 by 2. 2 columns, 2 rows. This is a 1 by 1 square, check. This is a 2 by 3, and this is not a square, since it's not the same rows as rows as columns. So for these questions, we have the determinant of a matrix happens to be a number that helps you find the inverses. So you use it to when you're finding the inverse or when you're solving a system of equations. So we're going to be finding this number that's called a determinant, like I said. So it helps you find the inverse. It makes things easier. So to find a determinant, start with a matrix that is a perfect square, which means, as we talked about in the warm-up, it has to have the same amount of rows as it does columns. And let a matrix, in this case, be A, B, C, D. You'll see these same letters, so it's going from left to right, like you would read a book, basically, I guess. So therefore, the determinant is found by doing this process right here, which is multiplying A times D and subtracting B times C. So you multiply these numbers, and then you subtract the answer of multiplying these numbers. So it's this product minus this product. All right, fairly easy. Let's do a couple products of these. And keep in mind, you have to have a square in order to find the determinant. If it's not a square, you can't do it. So first we multiply, so 5 times 0 is 0. So I like to always put the numbers right here. So this is the number I put going diagonal from the left-hand side and going diagonal from the right-hand side. So 3 times negative 1 is negative 3. So if I subtract these, 0 minus negative 3 is positive 3. And this is the symbol for determinant. It looks like the absolute value symbols, which also looks like the vector symbols. They all use the exact same symbol. 7 times 2 is 14, and 6 times 1 is 6. Subtract these two, and you get 8 is the determinant. 4 times negative 3 is negative 12. Subtract. 11 times negative 1 is negative 11. Remember, minus and negative is really like plus, so this is negative 12 plus 11, which is negative 1. 5 times 4 is 20, and then 3 times 8 is 24. Subtract these two, and you get negative 4 is the determinant. Okay, seems fairly easy so far. The blank of a matrix. So the inverse of a matrix is similar to the reciprocal of a number. The inverse of a matrix can be written as, I think I have this answer here as well. No, I don't. Okay, so we're going to show how to find that inverse of that matrix. So that's what was intended there. So when you multiply a number by its reciprocal, you end up getting 1. So if I am multiplying, let's say, 5, the inverse of that would be 1/5 because its product is 1. So the inverse is whatever number it takes to get a product of 1. So when you multiply a matrix by its inverse, you will happen to get what's called the identity matrix. And the identity matrix happens to be this set of, and I don't think I have this put in here. Yeah, okay, so the identity in this case is going to be when you have ones going across like this and zeros for all of the other places. Now, it doesn't matter what size this square is. So if it's a 4 by 4 matrix, it's going to be ones going diagonal and zeros in all the rest of the places. It's always going to look the exact same when finding the inverse. So that's called the identity matrix. So the identity matrix, so in this case, is found by multiplying 1 over the determinant. Basically, you divide the matrix divided by the determinant, which is the same thing as 1 over the determinant. And what you do is you take these numbers and you switch them. So the A is going to go over here and the D is going to go over here. And then the B and C's have to change to the opposites, which you can see clearly right here. So if this is the given matrix, I switch the A and the D, and I change the B and C's to their opposites. And then you divide that by the determinant, and once again, dividing something by the determinant is the same as multiplying it by 1 over the determinant. Okay, so recall the determinant is equal to AB minus BC. I need to move myself. AB minus BC is how you find the determinant. So we're going to find the determinant here first. So A times D, so 4 times 2, minus B times C. B times C in this case is 1 times 6. So 4 times 2 is 8. 8 minus 6 is 2. So now I know the determinant is 2. So the inverse is found by 1 over 2. So that's 1 over the determinant multiplied by, remember, I'm going to take these numbers and I'm going to switch them. So the 2 goes here and the 4 goes here. I switch the 2 and the 4 of their spots. And the 1 and 6s change to their opposites. So if it's negative, turn it into a positive. If it's positive, turn it into a negative. So now you have this, and then all you have to do is simplify this. So this is going to turn into, let's see, 1/2 of 2 is 1. 1/2 of negative 1 is 0.5, negative 0.5. And 1/2 of negative 6 is negative 3. And 1/2 of 4 is 2. Okay, so now what I want to do is prove the identity matrix. So as we talked about before, the identity matrix means you're going to have ones diagonal from top left to bottom right, and all the numbers are going to be 0. So any matrix times its inverse, which is this, should always equal the identity matrix. So let's prove that now. So let's take, this happens to be matrix A, and then we multiply it by its inverse, which is 1, negative 0.5, negative 3, 2. Okay, and that's going to equal what? All right, so now if I want to find the first row, first column, I'm going to multiply the first row times the first column. 4 times 1 is 4, and add that to 1 times negative 3. Okay, so if I want to find the second row, so I'm going to multiply second row, first column, 6 times 1 plus 2 times row times first column. Yeah, so 2 times negative 3. I got to be careful. And then for this spot, this is first row, second column. So first row times second column. 4 times negative 0.5 is 4 times negative 0.5 plus 1 times 2. All right, and then down here, it's going to be, this is second row, second column. So I'm multiplying second row times second column. So that's 6 times negative 0.5 plus 2 times 2. All right, so now let's do the math and see what we get here. So 4 times 1 is 4. 4 plus, okay, so we got something wrong here. So that's first row, first column. Oh, negative 3. Okay, I knew something was wrong there. That's negative 3 there. So 4 plus negative 3 is 1. Check. So that equals 1. And this is negative 2 plus 2 makes 0. That's correct. 6 plus, okay, so something's wrong here again. So once again, this is negative 3. That should be negative 3. So this is 6 plus negative 6 is also 0. This is negative 3 plus 4. So negative 3 plus 4 is 1. And boom, we have the identity matrix as our answer. And that's exactly what we wanted. All right, so moving on to, actually, I'm going to stop it right there, and I'm going to let you continue the rest of them on your own. Thanks again for watching. Please give it a like to help you learn how to find the determinant, or using the determinant in order to find an inverse. All right, thanks again for watching. Have a great day.